Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at debugging, specifically how to debug using both command line arguments and files. This video is part of a larger series of videos focusing on various aspects of debugging, and it also assumes that you have watched the earlier videos focusing on the setup of the NetBeans IDE, as well as how to include command line arguments in your project settings so that you can pass them to the debugger when you are debugging your executable. So the first thing that you want to do is obtain a copy of our debug_file_01 snips file, as well as our input_01.txt. First, what we'll want to do is go ahead and copy over the function prototypes over to our list of function prototypes in our debug driver.c, as well as the stub of our function. And we'll simply paste this then at the bottom of the file. At this point, you can go ahead and close your snips file. And then what we'll want to do is update our list of functions in our help, as well as the arguments in our if statement, or the triaging of our arguments from the command line. So we'll begin by taking a look at the function signature associated with our debug file_01. And particularly, you'll notice that it is expecting a file name. And in this case, for this demonstration, we are going to pass that file name from the command line arguments, or we're going to obtain it from the command line arguments, which means that in addition to the argv_1 that tells us the functionality that we're wanting to test, we must also have an additional command line argument that reflects which file we wish to open. So what we'll want to do now is we'll want to add a additional else if, and specifically what we want to do here is we want to check two things. Number one is that we want to check that our arg count is in fact equal to 3, because we'll have a total of 3 arguments: the executable itself, the first switch that indicates the functionality that we're wanting to test. In this case, we want to test our debug_file_01, and then the name of the file that we wish to import or to read. So in this case, then we'll want to check to make sure that we have a total of 3 arguments, and that our string compare I can match our argv_1 with the appropriate switch. In this case, it's going to be debug_file_01, and that, of course, has to be equal to 0. We should also note at this point that our debug file function accepts a single input argument and returns an integer output argument, much like our earlier example for the debug arguments. So in this case, what we can do is we can capture the results, and what we can do now is we can utilize the debug_file_01, and what we will do is we will simply pass to it our argv_2. Now, normally we're not going to be this cavalier about passing arguments, but in this particular case, our focus for this video is not on the error checking of the arguments themselves, but rather the process of debugging. So what we'd like to do now is we'd actually like to take a look at the function itself. And essentially what we want to do is go through the steps of opening this input file, or a file very similar to it that contains integers, and we're simply going to store them in an array. That's all we're going to do for this particular example. So the first thing that we want to do is we want to create an array, and we're going to call this chunks, meaning that it's just going to be chunks of data, and we're going to hard code the value of 100 in it. So basically at this point, I'm going to create an array of chunks with 100 elements in it. And remember that we have declared this, but we have not initialized it. So at this point, then all of those values that are stored in the array are essentially junk or nonsense. We also want to go ahead and capture the single chunk out of a file. And so this is the single chunk captured from the file using a scanf, fscanf rather, and these are all of the chunks in the file. At this point, we also need a input file pointer, which we're going to use then to open the file. And since we are ultimately going to return an integer, we also want to have some sort of results. And in this case, what we're going to do is we're going to count the number of elements read from the file. And so our results will essentially represent the number of elements retrieved from the file. All right, so let's go ahead and get started. We may deem that we need to add some more variables as we go along, but we're going to start with these. And the first thing that we're going to want to do is simply test to see whether or not we actually have a reasonable length file name. And so the first thing that we would want to do here is use our string length function to check the length of the file name. And there's various different things that we can check here, including looking to see that there is both a name and a file extension, as well as a period. We'll cover the validation of file names in later videos, but instead what we want to do is just verify that this file name is in fact greater than 0. And if it's greater than 0, we attempt to open it. Else, we simply print a message to the user that says error 0 length file name. And at this point, then, we need to decide what our default results should look like. We said that we wanted it to be the number of elements retrieved from the file, so the logical default for our results should simply be equal to 0. And at this point, then, what we can do is return our results. Now, under the assumption then that we have a somewhat valid file name, we haven't done all the validation we should do, but at least we have something for a file name, we should attempt to open it. And in this case, what we want to do is we want to say input is equal to fopen, and we want to open our file name, and we want to open it for reading. At this point, then, we need to check to make sure that our input file pointer is not equal to null. And if it's not equal to null, then that means that we've successfully opened it, and we want to start reading it. And then under the else, well, we need to once again warn the user or prompt the user. In this case, we're going to say printf error failed to open. And I'm going to go ahead and include a %s in here, which will allow for us then to pass to this printf function the name of the file that we attempted to open. And notice that we're using a %s here because we're assuming then that this file name is in fact a string. Now, going back to the true branch of our if statement, in other words, if the input file pointer is not equal to null, then we need to start reading from it. And in this case, what we'll do is we'll simply set up a while loop using our fscanf, and we want to use our input file pointer. And remember that our file, at least for this sample, is going to be integers. So our format spec here is going to be a %d, and we want to simply store it at the location of the variable chunks. And if that is not equal to end of file, then we simply continue reading it and storing. And what does storing mean? Well, storing simply means that we take our chunks variable, which is our array, And we're actually going to use our results variable, which you can sort of think of as an index variable here. And we're going to store that chunk at the current location specified by the results variable, or if you want to think of it as an index variable, inside of our chunks array. Once our while loop completes, we want to remember to go ahead and close our input file. And then at this point, it probably wouldn't be a bad idea to make sure that we don't accidentally read more data into our array than what we have allotted. And so in this case, what we'd like to do is add one more condition to our while loop. Specifically, what we want to do is we want to only continue reading while our results are in fact less than 100. So we have a compound condition here, meaning that while our results are less than 100 and fscanf returns not equal to end of file. And so at this point, what we can do then is we can simply stop reading once we have hit 100 elements read from the file, which means then to prevent us from having a infinite while loop, we want to make sure to increment our results, or I guess in this particular case, we would be okay because we have in fact got a file that only has 100 elements in it. In fact, we probably wouldn't wind up with an infinite array, or an infinite loop rather, because our array would essentially be, writing to our array would essentially stop once we hit our end of file. However, though, our results being less than 100 just simply prevents us from overriding past the end of the array. At this point, then we should effectively have our demo set up. And so what I would like to do is just go ahead and build it. We have a couple of minor changes that we want to make in our main once we have got our function working. Particularly what we want to do is print out the results. So much like we did before, we'll simply have results equal to %d followed by a new line. And then whatever value then was returned by the function, we simply print to the command line. And then the other thing that we want to do is update our help. And in this case, we want to have our debug demo.exe. We want to provide it with our debug_file_01 switch. But more importantly, we also want to provide it a sample input file. And in this case, it's going to be input_01.txt. And at this point, just add a little more information. So attempt or show how to debug with a file. And once again, just a little bit of extra cleanup. I encourage you to spend more time with this when you have free time. And also note that we assume that any text file that's being passed here is in fact going to contain integers. At this point, we should be ready to build it once again. And if we haven't made any mistakes, we should have a successful build. And we'd like to come back to the command line. I'm going to go ahead and clear my screen. I'm going to rerun my debug demo with a question mark or a /h. And in both cases, we should get our help. We have a little typo in our help, easy thing to fix. And then at this point, then what we can do is actually test our function. Specifically, what we want to do is test our debug_file_01, but let's intentionally forget to pass a file name. You'll notice that we don't have enough arguments, and instead what we end up getting is the implicit call for help, which then reminds us that we have to add our file name. And in this case, what I'm going to do is add our input_01.txt and hit enter. And you'll see that our results are equal to 0 and that we have failed to open our input_01.txt. And if you type in dir, you will in fact see that there is no input file in the same folder as our debug demo. And that's a pretty easy thing to fix. The first thing that we want to do is open Explorer in the current location. And what we'll do here is we will simply copy our input_01.txt to the same location. And now when we rerun our debug demo with the correct arguments, you'll see that we have 100 values that have been returned. Now, one of the things that we can do inside of our debug file demo is when we are capturing the individual values, it probably would be a little less disconcerting to simply have a printf in here that would allow for us to see what the current value here is. So what we'll do here is we will say something like chunk and then %d is %d. And what we'll do for this one is we will simply we'll simply use the first %d to hold the results, and the second %d would simply be the individual chunk. And at this point, and this should probably provide a little more feedback back to the user, a little bit more confidence inspiring. And so we're going to rerun this, and you'll see that there are all of the chunks. And specifically, I'm starting with my chunk 0. And the reason for it being is even though it is on line 1, remember that C is 0 based. Now, that's not what we're here for. In this example, our goal is to show how to do debugging with files. And so what I'd like to do now is I'd like to go back to our debug demo. I would like to right click and go to properties, and essentially in the run command I would put the same arguments that I would otherwise put in the command line, specifically my /debug file _01 and my input_01.txt file. And so I'm going to go ahead and carefully copy these arguments, and I'm going to come over, and I'm not going to delete the output path, but I'm going to very carefully paste those arguments into NetBeans. At this point, we'll hit apply and hit OK. And just like in the earlier examples, I want to come up to main, and I want to go ahead and put a breakpoint at the start of my triage tree, because we've seen this code in action before. We have no concerns about whether or not it works correctly. And at this point, then, what we can do is go ahead and either debug your project up in the main menu up here, or we can right click on the node for your project and select debug. Now, I was very careful about where I put that first breakpoint because I knew that this code would run successfully, but more importantly, it's going to show us some very useful information. Specifically, if you'll note here, the path for the executable. And so you'll note here that we are in the dist debug min-gw and the debug demo.exe. That's the name of our executable along with the full path. You also see that we have our argument *1 and our argument *2 for a total of 3 arguments. Now, if I step into my if statement, into my triaging here, you'll see that we successfully passed the first one, the second else if, the third, and now we're at the fourth. And if you were to come down here to your expression evaluator, you could verify that your argc was in fact 3 and that your argv *2 was in fact the file name, and your argv *1 was your debug file switch. At this point, you would expect for us to drop down into this branch of the if statement. If in fact it did not, what you can do is simply copy the string compare and paste it down here where it says expression, and you can simply verify whether or not you get 0. And in this particular case, since they match, you would in fact get 0. At this point, we've dropped down into this branch of our else if. We can continue to step one line of code at a time, which is going to bring us into our function. And then we'll go through some of the basic triaging, particularly to check to see if our string length is in fact greater than 0. And sure enough, because we have provided a non-zero length string, which you can prove by once again copying that code down into the expression evaluation, you'll see that my string length is in fact 12. Now, we are inside of the true branch of our if statement. We now attempt to open the file. And this is where things get a little strange, because you'll see that if I come down here and I test my input file pointer, I do in fact get null. Well, what's wrong here? Well, that's effectively saying that even though we passed a valid file name, we didn't open the file. And if you think about it for a second, that means that the name of the file was correct, but the location was in fact not correct. And as a matter of fact, we'll let this play out and you'll see that it's going to go ahead and print a statement that says failed to open the file. And you can come over here and see this in the console. And so once again, you'll see failed to open our input underscore o1.txt. And at this point, what we'll do here is go ahead and hit continue, and it'll return control back to the main. And in this case, it'll simply print out that my results were equal to 0. No data was read from the file. Well, how do we fix this? Well, it turns out that with NetBeans and MinGW, you have to have a copy of the input file also in the root of the project folder. So in this particular case, I would have to have a copy of my input underscore o1.txt in the MinGW directory when I'm running it from the console. But when I wish to debug it, I need to have a second copy of the file in the debug demo folder. In other words, whatever the name of your project is, you also have to have your input file there. To see this now work, we can come back, we can start over with our debugging by right-clicking on the project. We'll go to properties. You'll see that all of this is okay. We'll hit apply, hit okay. We'll once again right-click, go to debug, and we're once again going to go through some of the basic steps here, check our argument count. It's in fact 3, and you see that we have successfully passed the switches we intended to, and we go through our else ifs until we hit the 4th else if, and we drop down into that 4th else if. And in this case, we step through our debug file underscore o1. And just like before, we can verify what the file name is. We can also verify the length of the file name. And if we step once again, we'll go into the true branch of our if statement. We will attempt to open the file. And in this case now, with the file copied to the correct folder location, we get a non-null file pointer. And in this case, this means that we have successfully opened the file, which means that we can now debug while reading from an open file. And to understand how this works, then we're going to continue to step. We'll notice that our results are equal to 0. And so this part of our condition is true. We're then going to run our fscanf, which is going to read a individual chunk of data out of the file. Where did it get 9 from? Well, it turns out that 9 is the first value in the file. We also want to take just a second to remind ourselves that the chunks, plural, is essentially nonsense at this point. It's basically just a bunch of garbage values, and you can confirm this by going over to the variables window, and you can see the wide range of values, including a -2 in there, -2 again. Essentially, it's junk. But as we continue to step through this, particularly on line 142, you'll see that my chunk that I have pulled out of the file has now been placed in the first position in our chunks array, or chunks square bracket 0 is now equal to 9. The rest of the values have not changed, only that first one has. And we, once again, you'll see on the next line that we increment our results, and you'll see that they are now 1. I'll loop back around. 1 is still less than 100, and there's still data to be read from the file. And at this point, you can just play around with this for a little bit until you're satisfied that what I'm doing here is I'm simply reading in the values from the file, one value at a time. You can see there's my 9, there's my 10, there's my 2. The rest of it is still nonsense or garbage or junk, whatever helps you remember that you have to initialize your variables after you declare them. But at this point, what I'd like to do is I'd like to put a breakpoint on 145. I can then hit continue, and it will simply continue to process this while loop until one of these conditions are no longer true. And you'll see here that the last chunk that was read was the number 4. And if you come down here, you'll see that 4 was in fact the last value in the file. And we can also check to see that all of the data was read in by checking our chunks variable, and you'll see all of the values are now stored in the array. And then lastly, what you can do is check to see that our results are in fact 100. So at this point then, we should be satisfied that this function is working exactly the way we wanted it to, at which point you can step, step, step. And then now we are back in our main. We can print out the results to our command window. You'll see that results are equal to 100. And basically what we've done is we've printed out all of the data that we saw earlier on our console, but in this case in our debug console. At this point, we can then hit step, step, or simply stop debugging. Either way, we are done debugging this particular instance of our application. I'd like to take just a second to point out one other minor thing. So what we'll do here is once again go ahead and set this up for debugging, but this time what I'd like to do is I'd like to put a breakpoint on line 136 so you can see how you can skip ahead in your debugging once you're satisfied that certain portions of your code are in fact working fine. And particularly what we're going to do is we're actually going to turn off this breakpoint. And you'll see that I can still accomplish the same thing as I did earlier. It's just going to execute all of the code that we have already identified as good. In other words, it's not going to stop until it hits the first breakpoint inside of our debug file. All of the earlier code has in fact already executed. The second thing that I want to point out is that after you open the file, if you go into the variables window, you'll see that you have your input file pointer, but you can also watch how it increments through the file. And specifically what we're going to do is we're going to make a couple of steps through our file, just like we did a few minutes ago. And in this case, what we're going to do is we're going to go ahead and load the load the first line of the file or the first value of the file into the chunk variable. We're then going to put it into the array. And then when we come back around, you'll see that my pointer for my input file has actually moved forward, and you can see what it's looking at. And if you hover very carefully over this, you'll see all of the characters that are in your file. So essentially this is a way of looking ahead to understand how then your fscanf reads the values out of the file. Those /n's, by the way, are your new lines that put each value on their own individual line. So at this point, we can go ahead and stop. And I hope that you found this video useful. As always, if you have any questions or comments, don't hesitate to email me, and thank you for watching.